Welcome to this session on Introduction to 3D Modeling and Texturing. In this session, we shall discuss basic modeling concept in 3D. Let's discuss polygon primitives. Autodesk Maya provides 12 predefined 3D geometric shapes called polygon primitives. They are sphere, cube, cylinder, cone, plane, torus, prism, pyramid, pipe, helix, soccer ball, and platonic solids. You can use these primitives with their default shapes, or you can modify them for further modeling tasks. These surfaces can save you time in creating simple objects and give you a head start on creating more detailed shapes. You can change each of these primitives' default attributes in your options dialog box before you create an object. Polygon primitives have a construction history that lets you adjust the properties of polygon primitive after it's been created. The attributes associated with the construction history appear in your input section of channel box under the poly plus the primitive's name. In Maya, you can create the polygon primitives using any one of the following methods. Using the main menu, you can create a polygon primitive by selecting it from the Create Polygon Primitives menu. A polygon primitive is created at the origin of the scene using the polygons shelf. The polygons shelf let you quickly create most of the polygons primitives. From the polygons shelf, select the icon of the polygon primitive you would like to create. The primitives created at the origin of the scene. Using the hotbox, hold down the spacebar key anywhere in the scene to display the hotbox. From the Create menu in the hotbox, select the Polygon Primitive submenu. Select the name of the primitive you want to create. A polygon primitive is created at the origin of the scene. Using the interactive creation, we can create any polygon primitive interactively with multiple click drag operations in the scene view. The number of click drag operations varies depending on the primitive type. From the Create menu, select Polygon Primitive submenu and turn on the interactive creation option. This lets you create polygon primitives interactively. Hold the Shift and the Control keys during primitive creation to achieve the following effects. Control grows the plane and cube primitives from their center. This does not affect on all the other primitives. When adjusting primitive attributes in the subsequent interactive steps, pressing the Control key momentarily reduces the mouse speed. Using the Shift key, constrains all primitives to 3-dimensional equilateral proportions and grows them from their base. When adjusting primitive attributes in the subsequent interactive steps, pressing the Shift key momentarily increases the mouse speed. Using the Control Shift option, constrain all primitives to 3-dimensional equilateral proportions and grows them from the center. These are the common settings for polygon primitives. There are a few common settings for all polygon primitives to customize their creation. They are displayed in the option box of each primitive. Almost all primitives allow you to subdivide along the height axis. The exception is helix, which subdivides per coil instead. Primitives with radial symmetry allow you to subdivide around the axis. These include spheres, cylinders, cones, tori, pipes, and helixes. Primitives with caps allow you to subdivide the caps. These include cylinder, cones, pipes, and helixes. The plane allows subdivision along with the width axis, and the cube allows subdivisions along both width and depth. The round cap option allows you to create a round surface for the cap only when you increase the cap divisions. Now, creating UVs. UV mapping is the stage between modeling and texturing. It is an important aspect of creating textures for your 3D models. Creating a good UV layout allows us to tell Maya how to apply the 2D texture images that we create. If UVs are not present on an object or polygon primitives, you cannot see the mapped textures. This happens if you inadvertently create a primitive object with the create UV options turned off. The create UVs option assigns UV texture coordinates on the primitive for texture mapping. The various normalization settings fit with the UVs within 0 to 1 texture space. Normalize collectively and preserve aspect ratio is the default setting. If you turn off normalize option, the applied texture will not resize and it remains its true size. Normalize collectively option maps the texture over each face of the primitive and normalizes it so that it covers the entire object. You can also normalize the texture for each face separately. We will study the UVs in detail in the coming sessions. Let's talk about the basics of modeling in Maya. Modeling in 3D is different from conventional 2D drawing process. Imagine working with wire. You first place wires that determine the basic shape of the object and then cover the wires with a surface that can be positioned to create motion for an animation. Cover the surface with a skin of almost any material you can think of, set up lights and take a picture. This is essentially how Maya works. The surface can be shaped and refined in real time using 4 views. You can build 3D surfaces in many ways. For example, you can start by extruding a 2D curve, revolve it or draw boundaries that define it. Then cut areas out of the constructed surfaces by trimming them. When you are satisfied with the model, you can turn the surface into a photorealistic image by adding textures, colors, highlights and backgrounds using the rendering functions and options provided. Using ray tracing to add highly accurate reflections, refractions and shadows for surfaces such as glass and water. And to complete the image, you can add natural phenomena like fog, sky and sunsets. Non-uniform rational B-Splines or NURBS are a special type of spline you use to create smooth curves in surfaces. The curves and surfaces are defined by a set of control points which influence the object or shape in their vicinity. The overall object shape is determined by the way the control points are distributed in space. As you move the control points, the curve or surface changes shape and follows the control points in an intuitive way that is easy to work with. With that, let us talk about curve tools. Maya provides 3 curve creation tools. Surfaces can be built from one or more curves using one of these methods. The CV and the EP curve tools. A CV or a control vertex is a point that controls the shape of a curve or surface. The CV curve tool is used to create free-form curves. CVs are placed one at a time and the curves is created when there is sufficient CVs to define at least one span. For a degree 3 curve, at least 4 CVs are needed and create a single span. The CVs can be manipulated using transformation tools to give localized predictable modifications to curves and surfaces. An EP or an edit point is a point that lies on the curve or surface. Use the EP curve tool to place points one at a time. The curve is created to interpolate them with one span between each edit point. Both commands create the same type of curve, but the way you draw with them is different. You will mostly use the EP curve as it runs through the points you specify. In most cases, that is the most convenient way to draw a curve. When using a CV tool, you will specify the locations of control vertices which act like weights that pull the curve into a curvature. The curve does not run through them. The smoothness of the curve depends on the degree of the curve. The degree can be adjusted by clicking on the rectangular box next to the command. An option box will open where adjustments can be made regarding the activated command. 1 degree produces linear curves and 3 degree will give you a cubic or a smooth curve. Let us go to the pencil curve tool. The pencil curve tool method is useful for sketching a curve rather than creating it by placing CVs or edit points. The pencil method lets you create a curve as easily as drawing a line on a piece of paper. Next, we will go about Bezier curve tool. The Bezier curves are a subset of NURBS curves that are composed of two types of control vertices, anchors and tangents. Anchors lie on a curve and determine the origins of the tangents. The tangents determine the shape of the curve and leading to an adjacent anchor. Since Bezier curves are a subset of NURBS curves, you can perform the majority of NURBS operation to Bezier curves as well. You can also perform NURBS operations on a combination of Bezier curves and NURBS curves. In general, an operation involving all Bezier curves results in a Bezier curve, while operation involving a combination of Bezier and NURBS curve result in a NURBS curve. Now, let us discuss the arc tool. The arc tool allows you to create an arc by specifying 2 or 3 endpoints and then manipulating the center point or radius. There are two main options, 2-point and 3-point arc. The options define how you can create the curve. The accuracy in curve creation. When accuracy is required in curve creation, there are several optional methods to assure the accurate construction of curves. That is to activate the grid snap option to snap to grid points, or activate the curve snap option to snap to a curve point. That is, activate snap, press mouse button, hold while dragging along the curve. Activate the point snap option to snap to a corner or a curve. First, activate the display of the corner points, display, NURBS, edit points and activate snap. Press mouse button and click on the corner of the curve. Another method is to enter the absolute or relative coordinate of the next point of the curve. Activate the curve command and define the first point, type in the absolute or relative coordinate to the next point. When you create a closed curve, you draw the last edit point or EP on the top of the first one with either point, grid or curve snap, or after creation move the last control vertex or CV on the first one. This may seem strange, but using this method results in a fewer problems when creating the curve in, for example, a loft action. This method is absolutely not meant for polygonal modeling. Let us discuss the basic transform tools in Maya. Transform of an object means 3 functions: position, rotation and scale. Each function has 3 components for x, y and z. So, transform contains 9 variables in total, 3 defining each function. In transform, you need to move, rotate and scale the objects to place it in the position you want. You can move, scale and rotate the primitive objects into its final position either by direct manipulation or entering the numeric values through an editor. In order to manipulate an object's transform, the basic tools required from the toolbox are select tool, lasso serves a similar purpose, the move tool for changing the position of object, rotate tool for changing the orientation of the object and the scale tool for changing the scale of the object. Maya provides many ways to select objects. You can select object individually, all objects in the scene, all objects of a specified type, objects of a specified name, all objects in a set, all objects in a display layer. These are the color codes for directions. Always remember this equation for the correct axis or direction. RGB equal to XYZ. In Maya, tool gizmos or manipulator handles represent 3 colors for 3 axes. Red indicates x axis, green indicates y axis and blue indicates z axis. Using the transform tools, when you are in the move, rotate or scale mode, you have several options for transforming the object. Generally, if you click and drag on the surface of a selected object, you can center point for the manipulator handles. You can freely move or rotate the object. In scale mode, the object scales uniformly. You can also click and drag on any of the handles to have this action constrained to that axis. Click the Move tool icon in the toolbox and then select the object you want to move. Maya displays a manipulator with 4 handles, one to move along each axis and one to move anywhere within the planes. Click on one of the handles as indicated in the figure. The selected handle changes color when active. The default color is yellow. If you double click on the toolbox icon for move, rotate and scale, you get an option for tools. None appear for scale, but at least an empty dialog box appears. A useful option in this dialog box is snap spacing. Use the rotate tool to rotate objects about any of the 3 axes. Click the rotate tool icon in the toolbox. Select the objects you want to rotate. Maya displays a rotate manipulator consisting of 4 rings plus a virtual sphere enclosed by the rings or handles. The color corresponds to x, y and z axis. Click on one of the handles as indicated in the figure. The selected handle changes color when active. The default color is yellow. Use the x, y or z rings to perform constrained rotations. Use the outer ring to rotate the relative to the view. When you rotate a component, Maya rotates it about a temporary pivot which is initially set to the center of the component's bounding box. In the rotate options, you can find the options to set snaps, which is helpful when you want to rotate objects in a discrete increments. A good setting might be 15 degrees to make it easy to rotate objects to precise, 30, 45, 60, 90 degree positions. Note that this is snapping happens only when you use a manipulator axis handle. Use the scale tool to change the size of the objects by scaling proportionally in all 3 dimensions. You can also scale non-proportionally in 1 dimension at any time. Click the scale tool icon in the toolbox and select the objects you want to scale. Maya displays a scale manipulator consisting of 4 handles. The color corresponds to x, y and z axis. The object component mode. When we create an object, it automatically changes to the object mode. In the object mode, objects are treated as a complete unit. To enable component mode, Maya offers various options. The select menu provides many options for object component selections. The hotkey F8 enables the object component modes, or select the object and hold your right mouse button. It will show the marking menu with various components. Select the desired component. The object component may be moved, scaled or rotated. Object component mode allows you to manipulate vertices, faces, edges, etc. This is where more direct modeling control comes into play. Majority of your time modeling will be using the component mode and shaping your polys. Component mode works with polygons, NURBS, subdivision surfaces and curves. Let us move on to Boolean operations. In Maya, a Boolean is an operation that is performed on 2 objects to create a single compound object. You can apply 3 different types of Boolean operations: union, difference and intersection. These objects must be overlapping or intersecting in some way. To select multiple objects or components, hold Shift and left mouse button and click. Applying a Boolean is quite simple. Select both objects and go to Polygon, Mesh, Booleans and select which Boolean operation you would like to perform. For NURBS surfaces, pre-selection of objects is not needed because Maya use tools for Boolean operations. Go to Surfaces, edit NURBS and Booleans and select the desired tool first. Then select the objects with the tool. If you are unsure which operation is the right one, you can always change the type of Boolean in the channel box later, assuming you have a history turned on. When applying a Boolean, Maya takes into account the volume of 2 selected objects and the space both the objects might share. The easiest way to understand Booleans is to think of the operation as a math formula. The first selected objects will be A, the second selected object will be B, and the compound object after the operation will be C. So, the formula goes like this: object A, Boolean operation, object B is equal to object C. This might seem confusing at first, but it will make a lot more sense once you have moved forward. Boolean union: A plus B equal to C. The two objects selected will be combined into a single object. All of the objects internally overlapping sections will be deleted. Boolean difference: A minus B equal to C. The second object that you select will be subtracted from the first object. This is a very useful tool for creating holes in an object. Note that the difference only works if both the objects share space in between them. You could also say that you are using object B to drill a hole in object A. The shared space will be the drilled hole and object B will disappear completely afterwards. Keep in mind that the selection order is of vital importance when keeping the difference operation. First selected object is A, second selected object is B. If you are unsure which object you selected first, take a look at the colors of the edges. Object A should be highlighted white, object B should appear green, assuming that you haven't changed your color output. The Boolean intersection, or A percentage B equal to C. Intersection deletes both objects and leaves only the shared space. As the name of the operation implies, object A and object B need to actually share space in between them, otherwise you will be left with no geometry after the operation has been performed. Maya creates a new shape node for the compound object, deletes the shape nodes of object A and object B, but leaves the transform nodes until the history is deleted. That means you can still move both objects after the Boolean operation has been performed to change the outcome. Use the outliner to select the transform nodes. History of object A and B will become combined in object C. If you apply a Boolean to an object that has a smooth proxy on it, you will destroy the connection to the smooth mesh and you will have to reapply the smooth proxy. It is not possible to use more than two objects for a Boolean. However, you can get around this by combining multiple objects into a single object before applying Boolean. Be aware that the Boolean operations are somewhat fiddly, with complex geometry that may fail to work at all or cause both objects to disappear entirely. If this happens, you might try to deleting the history of the objects. Use edit and delete by type history with objects selected. You should also delete the history of the objects after you are satisfied with the results of the operations to avoid difficulties with them later on. If deleting the object's history does not work, you can try adjusting the Boolean settings by clicking on the option square next to each one on the menu. There are only a couple of settings, so feel free to try adjusting any of them to see if it helps. You can return the operation to its default setting by clicking edit and reset setting in the operations options window. If none of this helps, you may simply need to try with a different objects or try to figure out another way to get the same effect. So, to summarize, Autodesk Maya provides 12 predefined 3D geometric shapes called polygon primitives. They are sphere, cube, cylinder, cone, plane, torus, prism, pyramid, pipe, helix, soccer ball and platonic solids. These surfaces can save you time in creating simple objects and give you a head start on creating more detailed shapes. You can change each of these primitives' default attributes in option dialog box before you can create an object. We can create any polygon primitives interactively with multiple click drag operations in the scene view. The number of click drag operations varies depending on the primitive type. There are a few common settings for all polygon primitives to customize their creation. They are displayed on the option box of each primitive. UV mapping is the stage in between modeling and texturing. It is an important aspect of creating textures for 3D models. Creating a good UV layout allows us to tell Maya how to apply the 2D texture images that we create. Modeling in the 3D is different from conventional 2D drawing process. Imagine working with wire. You first place wires that determine the basic shape of the object, Then cover the wires with a surface that can be positioned to create motion for an animation. Cover the surface with a skin of almost any material you can think of, set up lights and take a picture. This is essentially how Maya works. Maya provides 3 curve creation tools. Surfaces can be built from one or more curves using one of these methods. A CV is a point that controls the shape of a curve or surface. The CV curve tool is used to create free-form curves. The pencil curve tool method is used for sketching a curve rather than creating it by placing CVs or edit points. Bezier curves are a subset of NURBS curves and are composed of 2 types of control vertices: anchors and tangents. Arc tool allows you to create an arc by specifying 2 or 3 endpoints and then manipulating the center point or radius. When accuracy is required in curve creation, there are several optional methods to assure accurate construction of curves. Transform of an object means 3 functions: position, rotation and scale. Each function has 3 components for x, y and z. So, transform contains 9 variables in total 3 defining each function. In order to customize the object transformation, you need to move, rotate and scale the object to place it in the position you want. You can move, scale and rotate the primitive object onto the final position either by direct manipulation or by entering numeric values through an editor. In Maya, a Boolean is an operation that is performed on 2 objects to create a single compound object. You can apply 3 types of different Boolean operations: union, difference and intersection. These are certain assignments for you to work out. Try creating 4 furniture items by arranging basic primitives. Try creating 4 object designs using Boolean operations. Prepare a face shape using Maya curves. Prepare a paper based on the study of the differences in application of Maya curves. Prepare a presentation on the Maya transform tools. These are the books that I can suggest for further studies. Animation from Pencil to Pixels: Classical Techniques for Digital Animator by Tony White, Focal Press, UK. Computer Animation by John Halas, Focal Press, UK. Toy Story: The Art of Making of the Animated Film by John Lasseter and Steve Daly, Hyperion, US. Digital Modeling by William Vaughan, Pearson Education, US. Introduction to Computer Graphics and Creative 3D Environments by Barry Blundell, Springer, London. Art of 3D Computer Animation and Effects, the 3rd edition by Isaac V. Kurlow, John and Willie Sons, New Jersey. Hope this session was useful to you. We shall meet again with another session. Until then, bye.